All right, well, it is 11 a.m. Eastern Time, so let's get started. Welcome everyone to the final day of peer review presentations for Geog 596A, Fall 1, 2022. I'm Jim Detweiler, the faculty lead for the Geospatial Programming Certificate, for those who don't know me. We have 3 presentations today, but first, a few reminders. Presenters, you'll have 25 minutes to give your talk, followed by 5 minutes of questions. If you have a question for a presenter, please enter it into the chat box. You might consider typing your question into a separate text editor and then copying and pasting it into the chat box when the presenter wraps up, so you don't distract them during their talk. Presenters, please read the questions out loud so that anyone watching the recording will know what you're responding to. And 596A students, we're expecting you to provide each speaker with constructive feedback. Others who are in attendance, you're invited to do so also. And I will post a link to the peer review form in the chat box as we go. But first up, we have MGIS student Jordan Edmonds, who's going to talk to us about climate change in Ohio. Jordan, are you ready?
Yes, I am.
Okay, I see your slides and I can hear you, so take it away.
All right, great. If there's any, if I break up or anything like that, just let me know. Okay, so good morning, everybody. My name is Jordan Edmonds. Just a little bit about myself. I have a BS in Geological Sciences from Ohio University, and I'm currently working as a geologist in the Cleveland, Ohio area. My capstone project is titled Effect of Climate Change on Growing Season Length and Surface Water in Ohio, and my advisor is Dr. Gartner. So my presentation is going to follow this outline. I'm going to do a brief introduction and introduce my study area. I'm going to define my purpose and goals I hope to reach in my project. I'm going to present my data that I'm going to collect and why, and the methods I'm going to use to analyze the data. I'm also going to give a brief idea of some of the anticipated results I expect to see, and a timeline of the upcoming events I have, followed by a conclusion. So it's been well documented in research that climate change has severely affected the Earth's hydraulic cycle. The hydraulic cycle, I'm sure you guys all know, is the process that turns the planet's ice and water into water vapor, which then condenses in the atmosphere and precipitates back to the ground as snow or rain. As the Earth's surface temperatures increase due to climate change, so do the rates of evaporation and evapotranspiration. This results in an increased rate of precipitation. So the increase in activity is called water cycle intensification. It is believed that this intensification is a leading cause of increased intensity and frequency of extreme weather events like droughts, severe storms, and extended periods of heavy rainfall that will affect natural hydraulic processes like river flow velocities, water levels, and flooding events. So one question to ask is there an observable relationship between historical surface water and climate data? In addition to the water cycle intensification, due to the warming trend, phenological processes have also been observed. So phenological processes are reoccurring biological events of vegetation, like the emergence of leaves or buds and flowers. Vegetation phenology is also a key part in measuring the growing season length. So the onset of the vegetation is usually the starting indication of the start of the season. And then when all the leaves start to die, that's usually signals the end of the season. So as final freeze dates start to occur earlier every year, along with the earlier arrival of warm and humid spring air, these easily observable biological events also appear to be occurring earlier. So it's reasonable to assume that as the start of the season date creeps up, so does the growing season length. It also increases. So a question to ask is, do historical observations of phenological processes illustrate a change in growing season length? If so, can a relationship with historical climate data also be observed? So why Ohio? Well, besides being the state that I live in, Ohio has a unique variation of hydrological, geological, and land use characteristics. For starters, Ohio is divided into two separate major water resources, the Great Lakes region to the north and the Ohio region to the south. So the Great Lakes region, it encompasses all the watersheds that drain into the Great Lakes and is essentially a closed system with less than 1% of its total volume flowing through the St. Lawrence River into the Atlantic Ocean. The Ohio River Basin, on the other hand, is part of the much larger Mississippi Atchafalaya River Basin, all these smaller watersheds that are found in the Ohio region eventually flow into the Ohio River, which in turn flows into the Mississippi River. Ohio is also dominated by two land uses. So here's a map that I developed using the National Land Cover data set. It's mostly of Ohio with some bleeding into neighboring states. You can see that deciduous forests to the east and southeast are the dominant group. They account for over a third of the total land use, while cultivated crops is the second most dominant, almost accumulating for a third. There's also a big percentage of developed areas throughout the state, representing the major metros in Ohio like Columbus, Cleveland, and Cincinnati. Those account for over 14%. And there's some sporadic patching of hay and pasture lands throughout the state that account for up over 12% of land use. So the Ohio landscape is surprisingly varied due to the continental glaciation during the Pleistocene age, with most of the state, of course, falling into two different categories like the other two kind of characteristics. So there's the central lowlands and the Appalachian plateaus. So these central lowlands can be broken down into the till plains that are more towards the central and west. These are a mixture of heterogeneous clay and silt, sand, and boulders that were deposited by glaciers. There are some sporadic low hills in this area caused from recessional moraines, which are just formed by stagnant glaciers. So when a glacier just sits there and it doesn't advance or retreat, it's kind of just hanging out, it forms these recessional moraines that end up turning into hills. The other central lowland area is the Huron Lake Plains, and this is actually the historical lake boundary of Lake Erie during the last glaciation event. So towards the east, there's the Appalachian Allegheny Plateaus, which can be divided into the glaciated area and to the unglaciated area, unglaciated area. So the glaciated area to the northeast contains hills of low relief and broad valleys, while the unglaciated region is mostly a bedrock, and there's an abrupt transition in topography and vegetation. So this area has really thin, poor soils. That's unideal for agriculture, but instead this area has a thriving, dense, and expansive forest, which you could have seen in the land use land cover map. And finally, there's a fifth smaller region of the state in the southwest corner called the Bluegrass section. And this area is greatly dissected by streams and has high relief, mostly caused by the Ohio River. So for my whole study area, it's almost the entirety of the state of Ohio, with the inclusion of partial inclusion of 5 surrounding states. I'm including the partial states because I wanted to keep the river basins that I found in here complete. So there's a kind of a chunk missing out of Western Ohio. That's actually part of the Wabash River Basin in Indiana. And that pretty much makes up the entire state. So I kind of just omitted it. Otherwise, I'd have to include all of Indiana essentially and part of Illinois. Some climate data I got from PRISM. The mean annual precipitation ranges from 937 to 1,200 millimeters a year. Temperatures range from 10.1 to 12.6 degrees with an average of 11.2. The climate classification for the study area is dominated by hot summer humid continental, with a small section of humid subtropical along the southern edge of the Ohio River. And here's just a map of the 7 river basins that I divided from the larger Great Lakes Basin and Ohio Basin. So these are all major rivers in Ohio. So the purpose of my capstone project is two-pronged. First, I want to evaluate the impact climate change has had on the study area and watersheds found in Ohio. And second, I want to examine the relationships between growing season length, surface water properties, and climate and changing climate variables. So I plan to do this by answering the following questions. How has the growing season length changed across the study area? What are the most important climate drivers of growing season length? And what is the spatial relationship between climate change variables, growing season length, and water resources in the region? So for my project, I'm going to be using 4 different data sources. The first is GIMS. It's a global inventory model and mapping studies data set published in 2010 at the University of Maryland. Next is PRISM, the parameter elevation regressions on independent slopes model developed by the PRISM Climate Group at Oregon State University. I'll be using digital elevation models obtained through the United States Geological Society or Survey 3D elevation program. And I'll be getting hydrologic data from the USGS's Hydroclimatic Data Network and Historical Water Database. So the first group of data is the GIMS data. It's a remotely sensed vegetation indice. So these are used to detect greening and browning trends. It's a product derived from NOAA's advanced very high resolution radiometer data set from satellites. They've been collecting data from 1981 to 2006, to 2006 with well, they're actually still doing it, but the data I'm using is going to be running from 1981 through 2006 with an 8-kilometer resolution. So these satellites take 2 data points per month and present the data. The max volume is going to be from the first 15 days, and the max value of the remainder of the month is the second data point. So with these values, they come up with the NDVI, the Normalized Difference Vegetation Index. So that ranges from -1 to 1, and you get it by the formula near infrared minus red divided by near infrared plus red. So here's a little graph, a little chart of different land coverages and how they're displayed with the Normalized Difference Vegetation Index. So water is typically negative, with water and snow. The closer you are to 0, that represents barren land. Positive values represent vegetation. The higher the value, the more dense it is or closer to peak growing season. So this map, it kind of shows the water peaking at about 0.4, but that's also occurring during the summer. So that could have been caused by an algal bloom or something like that. So climate data will be obtained through PRISM. This model collects data from approximately 26,000 stations that spatially interpolate precipitation and temperature using digital elevation models. It's been collected from 1895 to the present and provides data sets including maximum, minimum, mean temperature, annual precipitation, max and minimum vapor pressure deficit, mean dew point temperature, and solar radiation. So I'm going to be obtaining DEMs from the USGS 3DEP program. I've collected 29 separate 1/3 arc second seamless DEMs. So the 1/3 arc second represents a resolution of 10 meters, which is the highest available for seamless DEM datasets. All this was published from 2017 to 2021. So there you can see the outline of my study area in white and the tiled DEMs that I combined into one raster layer. So next, the fourth piece is the hydroclimatic data network. This is a collection of USGS stream gauges in the continuous United States. These streams are unaffected by artificial diversions, storage, or other unnatural mechanics and remain in a natural state. They are intended to provide an unaltered account of hydrologic responses to fluctuations in climate. So the map shows the distribution of the stream gauges found in Ohio. This project that I'm going to be performing is going to use 24 of these stations to develop delineated watersheds that I'll use in my analysis. Mean stream flow and other hydrologic data will be obtained through the USGS historical water data set. So for my methods, there's four distinct groups. There's first watershed delineation. There's the pre-processing of the vegetation index data. There's processing of the vegetation index data. And then there's the spatial statistics of the data. So first, this is the final step I need to do to establish the project study area to determine which sites will be selected for analysis. The watershed delineation is an important step in identifying the watershed's boundaries and visualizing the contributing area upstream. So it's used to estimate the quantity of water that is collected and potentially discharged in a drainage area. It can be used to help manage peak storm flows and measure water runoff rates. So this process will occur in ArcGIS Pro. The first step, if there's a bunch of if you have a bunch of DEM files like I did, you have to use the mosaic tool to combine them into one. And then you're going to use that DEM file and run the fill tool on there. So the fill tool is going to correct any sinks or low points in the raster. These are typically just errors that are caused by resolution issues or rounding of elevations. This is an important step because if you skip this step, the drainage networks may become discontinuous, which would result in incorrect networks. So with that corrected DEM, you're going to use the flow direction tool on there. So this produces a raster that indicates the direction of the flow from each cell to its adjacent downslope neighbor. So each cell has 8 neighbors, and the tool decides which adjacent cell has the steepest decrease in elevation and assigns the cell a code that determines that's the direction that the water is going to flow. So with that new raster, you're going to use the flow accumulation tool, and this uses this calculates the total number of upstream cells flowing downslope through each cell. This is going to help illustrate stream channels, areas with high flow accumulation totals, and topographic high points. With that, you're going to use the snap pour point tool. So this tool uses selected feature points. In this case, it's going to be the watershed or the water stations from the HDCN database. These pour point tools have the highest flow accumulation rates and flow out of the area. So it's kind of what they're pinning the flow onto. So finally, with the watershed tool, this is the tool used to finally delineate the upslope area. It incorporates the flow direction and the pour points, and the end result is a raster of all the watersheds illustrating the contributing upslope area. And the last tool is just a raster to polygon, so it's easier to manipulate the watershed polygons in ArcGIS. So here's my study area after that process. There's 24 delineated watersheds. This is the kind of the hatched marks there. Each river basin, each of the 7 river basins have at least 2. There's also the different land uses. So the deciduous forests, farmland, etc. They're all represented along with the 4 major physiographic regions. So the Huron-Erie Lake Plains, Tilled Plains, and the glaciated, unglaciated plateaus. So for the vegetation index pre-processing, I'm going to remove all the data that is greater than 1 because that can't be true. It has to be between 1 and -1. And I'm going to get rid of values that are equal to or less than 0 because I'm only interested in vegetation. I'm going to utilize the TimeSat software. This software was specially designed specifically for handling this advanced, very high-res vegetation index data and to extract seasonal information. This program is going to remove spikes and outliers, and essentially it just smooths out the data. So here's a graph comparing unfiltered and filtered vegetation index data. It doesn't seem like much of a change, but it just makes it look nicer. So using the TimeSat software, I'm going to determine the start of season and end of season. So end of season or start of season is going to be when the amplitude reaches halfway up the amplitude. So that's the midpoint. The end of season is the opposite. So you're able to easily get the growing season length just by subtracting the end of season days by the start of season days. The TimeSat also gives you other seasonality parameters such as green up onset, dormancy onset, the middle of the season, maximum value, maturity, things like that. Let's see. So I'm going to be using regression analysis on the PRISM climate data and the USGS streamflow data. This is going to help understand the relationship between variables and evaluate key variables, and will also help make future predictions. So using ArcGIS Pro, I'm going to be using the ordinary least squares technique and the geographic weighted regression technique. So ordinary least squares, it's used to estimate coefficients of simple linear regressions. It describes the relationship between one explanatory variable to a dependent variable. So here's an example I have right here of what it kind of spits out. So this is comparing air temperature to land surface temperature. It basically just puts a trend line in between all the points and makes it fit the best it can. And you can come up with a slope and prediction based on that. So in order for the model to actually work, you have to go through 6 different checks. You have to check the coefficient values. Are you expecting a positive relationship and getting it, or a negative relationship? The explanatory variables have to have significance. So this one's easy to determine because the report's going to let you know if it's significant or not. The residuals need to be, can't be clustered. They need to be spatially random. And along with the distribution, they need to be distributed evenly. The various inflection factor needs to be over or less than 7.5. Otherwise, there might be redundancy in your variables, which will mess up your model, and you'll have to go back and get rid of and check to see which variable is the redundant one. And you want to look at the adjusted R² value to see how well the model fits. So this is a percentage, basically 1 to 100% or 0 to 100%, and preferably you want values to be about 65%. And finally, for the geographic weighted regression, it's similar to the ordinary squares, except that you're going to incorporate points to it, so locations. So in this case, it's going to be the water station locations of the watersheds. It's a more accurate explanation of the variables than ordinary least squares because it looks at the surrounding neighbors. It also spits out a executive summary, which has all these different statistics that you use to help explain the model. So similar, you want to go through those checks and see how well the model fits. So for my anticipated results, I anticipate that there's going to be an overall increase in growing season length observed in all of the watersheds across the state. And this is going to be due to an earlier onset of the start of season. I believe the specific humidity is going to be the greatest driver of the growing season length, mostly in part due to the warm, humid air triggering the start of the phenological phenomenon, starting the growth period. The greatest increase in temperatures are going to be observed in the western tilled plains watersheds, and the greatest increases in precipitation will be observed in the eastern deciduous forest watersheds. So for my timeline, I have all fall and winter to work on this. I'm going to be taking 596B in spring, the spring one, and I'm going to be presenting my results in March 23rd to the 27th at AG in Denver. And after presenting, I hope to possibly continue my project and possibly publish it while I wrap up the GIS program. So in conclusion, by the completion of this project, I hope to successfully explain the impact climate change has had on the study area in recent years, along with thoroughly explaining the relationships observed between growing season length, surface water properties, and climatic variables. I'm going to be doing this by looking at the growing season length by using time set analysis, looking at which are the most important drivers by using regression analysis, and looking at the spatial relationship between the variables, water resources, and growing season length by using regression analysis. So here are my references, and that's it.
All right, thank you, Jordan. Good job. Looks like you already have a question or two in the chat.
Okay, you have collected a variety of data sets for different periods. What is the period of time you would be analyzing to determine? So I'm going to be using that 1981 to 2006, the GIMS data set. That's the one that kind of shows you when the green is happening and then when everything dies away. Are you going to take in large-scale climate patterns? Are you going to take large-scale climate patterns into consideration as possible influence on the growing seasons, such as El Nino and La Nina, since both can have impacts on precipitation and temperature? No, I'm just going to look at just annual trends to the data. I mean, you could always have like a freak storm, like a hurricane that could actually come up, still reach, the bands could still reach Ohio and still flood everything. You could also have 100-year floods, but those are just kind of outliers that are going to be kind of, washed away. Kind of more focusing on just the Ohio area.
I had a question, Jordan. I was wondering if you considered looking at any model output for what climate change could bring in the future and seeing how that might impact growing season length in addition to looking back at what's happened.
That's part of the regression analysis, is looking at the prediction, and maybe a further project down the line could be seeing trends in growing season length and productivity of crops. And is growing season length increase a good thing or a bad thing? Is there a trend in crops kind of moving up north to different temperature zones or something like that? That's an interesting thing, because if you start predicting what's going to happen in the future, though, people might look at you and you're sticking your neck out if you're wrong.
Sure. Any other questions for Jordan? I'm going to paste in the link to the peer review form. There it is. Again, 596A folks, please make sure that you're filling out the form for each presenter. Okay, well, good job, Jordan. Thank you very much.
All right, thank you.
And that brings us to our second presenter, Kara Schindel, who's going to talk about designing and implementing a multi-jurisdictional GIS program. Kara, take it away. Not hearing you yet, Kara.
Okay, can you hear me now?
There we go. Yep.
Okay, I apologize. I have a significant amount of road noise where I am, so I had to call in.
Okay.
All right, well, good morning, everyone. My name is Kara Schindel, and I will be talking on my capstone proposal for the design and implementation of a multi-jurisdictional GIS program with advisement from Patrick Kennelly. During my presentation, I am going to provide some context into the background of this project and why I selected it, some of the objectives I've identified for the success of the program, and some considerations when we look at the implementation of this program. I will also go over some of the methodology for accomplishing some of the objectives and also the anticipated broad timeline and results as a result of this project development. I'm going to provide some context for this project first so that you can understand the feasibility of this project and why I chose this particular subject. This is a map of Franklin County, Pennsylvania. We are in south central Pennsylvania, right along the Mason-Dixon border with Maryland, and we are a mostly rural and agricultural county, but we have close to several transportation nexuses and have a lot of prime commercial manufacturing land along an interstate. This map shows the 22 municipalities, 7 of which are boroughs that make up Franklin County, and the boroughs actually hold most of the population. Interestingly enough, that interstate also runs right through all of the municipalities that have some form of an existing GIS program. The interstate, coupled with our proximity to Baltimore, has spawned more than one joke that we have big city problems without the big city resources. Now, I tell you this because I am the GIS director for Franklin County, and our GIS program is currently offered as an IT service to all departments within the county. We have been plagued with a general lack of education and awareness about GIS capabilities within the county. And when I took over in 2018, I embarked on an education campaign to help address some of our issues. This project is potentially the result of some of my efforts, but I take it with a positive light. I have been tasked by our commissioners with expanding our program to include municipal GIS support and services. This is a new facet of our program, and to my knowledge, we have not offered this type of service previously from any of our divisions. This project brings its own set of challenges. We are currently expanding into other areas within the county, and the county also does not have a project management office, a PMO, to provide support and resources for any sort of large-scale project creation. However, this program does provide opportunities too. It's going to involve the coordination of resources and the careful management of our current growth, and with the potential service offerings that we do not overextend our capabilities and potentially be unable to fulfill current or future obligations. To that end, the objectives for this program I have identified involve creating a formal process for the requesting, billing, and management of municipal GIS services, creating a tier of services with a phased implementation schedule for implementing those tiers, creating and updating a strategic plan to include our municipal end users for long-term internal planning. And I also hope to either get the results of at least one end user survey or the lessons learned from a potential test project. And I will go over some of the considerations for that test project. To accomplish the aforementioned goals, we do have to identify the different pieces for developing this program and prioritize and plan how they will interact with each other. The commissioners want us to charge for these services, but we must do so in a manner that covers our costs but isn't a burden on the municipalities. They have limited resources. One resource that a lot of municipalities rely on within Pennsylvania is called the liquid fuel funds offered by the PennDOT, our Department of Transportation for the state. Liquid fuel funds are used to repair bridges and roads, but they are based on petroleum taxes. And recently we have started to see concern over a decline in this funding with the increased usage of alternative fuel sources and electric vehicles. At this time, the replacement funding is not matching the pace of the alternative fuel and electric vehicle implementation. So another consideration is also that of something called Next Generation 911. What this is a continental-wide upgrade of aging 911 infrastructure that is moving to a GIS-centric model. Existing processes for the sharing of information between municipalities and the counties does not currently meet the expected legislative requirements for this program. What that means is that because Pennsylvania is a commonwealth, a lot of the burden or responsibility for maintaining things like addressing and information used in 911 dispatching falls to municipalities. There is no standard way of handling this, and every municipality either has their own set of procedures or they have given it to the county to do for them, which means that the county currently only addresses for about 1/3 of the municipalities within our borders or offers unofficial information or approval for addressing if the municipalities reach out to us. What this means is that there will need to be an adjustment on both sides as we navigate an increase in responsibilities without an increase in funding and resources to be able to handle these expanding legislative requirements. For example, currently there is a requirement that the municipalities give us addressing information within 30 days of creating a new address. Legislatively, NextGen 911 is expected to require that information within 2 to 3 days. What that means is that with the shift to a GIS-centric model, not giving the county the addressing information means that the municipalities may potentially delay dispatching of emergency services to a particular address and or face potential additional litigation issues. And that means that the adjustment on both sides and the need for additional workflows, improved business processes, or tools to exchange information is necessary going forward. The county also does not currently have a PMO, and while it is potentially in the works, the lack of project management knowledge and resources means that I will have to bear the brunt of that process while making sure we have appropriate reporting needs incorporated into the new program. One of the last considerations just from this development of a new program is timing. The municipalities are asking for varying and complex projects before the program is in place. I am being advertised as a resource, yet I do not have the safety net or processes in place yet to be able to serve as a resource to these outside partners. And then obviously developing the program itself means creating new processes and also integrating into existing ones just within the county, let alone the municipalities, to account for legal, billing, software, or reporting ramifications and needs. As I mentioned earlier, there are both challenges and opportunities for this program. This, through its use, could bring potentially improved services to the public, and expanding use of GIS within the county and introducing it to the municipalities, all while taking advantage of the perks that things like cost and resource sharing can provide, such as negotiation power or collaborative decision making. Streamlining both internal and external business processes through relationship development and the sharing of data can help improve not just this potential project, but also, address sharing like I talked about with NextGen 911, or sharing building permit processing through other departments. Some of the potential challenges include the county resources not being sufficient to support the municipalities with increased legislative pressure due to state or federal initiatives such as NextGen 911. One of the other issues is that we could have low buy-in or lack of inclusion with the end users, leading to potential for program failure and lack of support. The idea being that people support what they help build. We want to avoid putting this much effort into this program for potentially having low return or creating a program that just peters out in the future without any continued support. We also have to consider the need for tracking effectiveness and success or failure of the program as means of justification and implement tools for review and improvement. In my experience, government at all levels is rife with outdated reporting or none at all, meaning that inefficient processes persevere. When asked why, the general response of, "But we've always done it that way," has been used to justify many pointless workflows. And then a double-edged sword is providing that communication avenue, but I believe it is necessary for driving innovation and preventing program stagnation. A phased implementation approach with an associated communication strategy to avoid multiple pitfalls is what I have decided will be an appropriate methodology for this project. The idea that it will help mitigate lack of buy-in and or the inability to create and or find champions. This approach is designed to help slowly build resources and processes over time to avoid over-allocation of resources, especially when coupled with a list of priorities that we will identify in the planning process using a user-first approach. By adopting this user-first approach, we can design a program that offers pertinent services and transparency, with that helping to increase trust in the program and the staff and also encourage interest in the program in the future. The idea is that if we use that interaction with the users to develop a tiers of services that start off simple and become more complex as the program matures, we can help mitigate some of the potential pitfalls. A phased implementation can help control growth and avoid over-allocation of existing resources. The idea is that this will also help provide a schedule for coordination and planning of the different pieces of the program. It would also help us allow identification and prioritization of the different pieces of this program as we go forward and engage with the end users. It also allows us to consider different scenarios that may arise as we develop this program and how we would handle each. For example, what happens if we build a solution and someone else wants the same solution after it's completed? Do we charge the same to avoid issues with equal treatment, even though the second project may require less work, or should we consider offering project cost sharing? If we consider two adjacent municipalities wishing to implement a sewer utility network and field collection project, could they share the cost of the project, thereby lowering the overall burden for each participant? This phased implementation is I'm looking that this phased implementation will have deliverables such as a schedule, which allows for inclusion into our long-term strategic planning, and also will help identify communicated needs from the municipalities that we can then translate into the tiered service offerings. All of this, I think, would not be possible without implementing a communication strategy. Communication is necessary for not only developing the program by including the end users, but also for the continued success of the program into the future. Including the end users helps with developing applicable and relevant service offerings. Ongoing communication assists with ongoing education efforts, always something that you have to do in this sort of project, and also encourages interest in existing projects. The idea is that a communication strategy will also help us build a brand and locate potential champions to assist with ongoing communication efforts. If you make someone happy, they're willing to talk about how you help them improve their overall work lives. Various methods of communication forms can range from focus groups to email blasts, newsletters, surveys, or new participation onboarding materials, otherwise known as elevator pitches unofficially, that can also help entice new participants. Practically, a communication strategy can also help mitigate frustrations with future maintenance and support needs. Inevitably, something always breaks, and being able to communicate with the end users in a timely and ongoing fashion can help mitigate frustration on both sides. In this instance, a user-first approach involves the end user in the development of the program and offerings in order to establish a dialogue in which all the parties can communicate their interests, their priorities, and their criticisms. This also encourages a sense of ownership in those that help build the program. It also helps us allow for services and a program to be relevant according to shifting priorities and needs of the end users by giving both sides an avenue for sharing information. And this is coupled with the ongoing communication strategy. Through my readings and research, I have seen that there are multiple ways that we could create this program. Not building in the necessary tools to guide and manage growth can cause bigger issues or potential program failure down the road. We do not want to overextend ourselves and potentially leave our existing customers hanging. The intent is to adopt the phased approach and to slowly implement control measures such as project management and reporting to help mitigate wild growth and prepare for potential challenges. Using a lot of the project management techniques learned throughout my time with the Penn State campus program. I intend to do this by also developing tiers of service offerings. Tiers implemented via the phased approach allow for better management of resources. They will grow as our abilities and resources grow. The tiers would start off by offering the lowest effort services first to help with adjustment on both sides for the new program as it's implemented going forward. And it would also allow the municipalities to get comfortable with initial offerings. The idea being that controlled exposure allows them to develop comfort with increasingly complex projects and helps with resource management. From my experience, getting new staff in local government is not a quick process. So if we have immediate uncontrolled growth, we're going to then be left with overallocated resources that can't keep up with the demand. In order to establish this program, I have come up with a development timeline. Notice that regular communication occurs over the entire course of the development process and will also continue into the future over the life of the program. The phases are designed to slowly introduce the new process and offerings for both sides, allowing for the management of resources and funding. Notice that user engagement is developed first, especially with the onset of surveys and trainings and materials to help communicate the different offerings and phases as we move forward so that everyone that's participating can move forward together. Some parts of the program, such as billing and legal agreements, need to be in place before other parts, such as ROI reporting. And while all parts are important, some are needed before others, which is where the phased approach and implementation comes in. To that end, I have identified some anticipated results due to the complexity of this project and also due to the fact that we are somewhat controlled by other decisions and priorities. I've identified the following results for this project as it moves forward. First, I would like to create a draft strategic plan used primarily by myself and our guiding GIS committee internally for stakeholders and for future planning. This is to make sure that it will be updated to reflect the additional priorities and new end users. There are not really any known consequences of not doing this, except that a lack of a clearly outlined vision as it incorporates all the aspects of the program going forward would be helpful to our case. I'm going to actually skip the second one and move down to next, the visioning document that I think should include pertinent information about the program, its components, and the considerations that went into the decision-making process. I really envision this laid out like a project charter, and it could also then be useful for onboarding internally as resources shift and change within the county itself. I would also like to develop the initial tiers of service offerings going with the phased implementation approach. This does tie into the control of the program growth and the incoming requests and helps guide and inform the municipalities on what is possible. It also allows for planning in regards to things like maintenance, support, and staffing, to name a few considerations. Then, ideally, I would also like to have at least the results of one user survey. Potentially, there is interest from municipalities that may necessitate a project occurring before the program is developed and in place. So if we do end up with a test project before the program has been fully developed, both the user survey and the test project will provide opportunities for lessons learned and also will help us with insight into the development of the program going forward. So that is what I have. Does anyone have any questions?
Thank you, Kara. It looks like you've got a question in the chat.
Okay, the question from Caitlin is, what type of GIS services are these municipalities looking for? Utility mapping or more like general parcel/tax mapping? Or what type of services are you looking to offer to these municipalities? Well, the short answer to your question, Caitlin, is yes. The municipalities are looking for a variety of offerings that range from just integration with our current offered feature services such as parcels and or addressing and road information, all the way up to complex utility mapping and field data collection. I've actually had 3 separate phone calls from the last 2 months where they have multiple field personnel retiring that hold all of their valuable utility information within their heads, and they're looking to translate this into GIS data that can help them going forward and improve their business processes. What I'm looking to offer from them is to start out simple with maybe the implementation, or allow them to have access to our ArcGIS Online accounts or space on our own internal servers, integration with some of our existing feature services so that they're not manually integrating parcel data, and then also expand into more complex projects over time. Okay, so from Fritz, I have the question, what kind of timeline do you expect until this project is implemented, and how much cooperation about this project are you finding on an individual municipality level? So timeline, this project is happening now. It was tasked, I was tasked with it, so I have to kind of play a little bit of catch up, but we're also looking at hesitancy on the side of the municipalities. For one, the county as a whole just started offering these services without any sort of communication, which is why I think the communication strategy is very important. I've had several municipalities that I've talked to, and we're in the process of drafting cost proposals for one-off individual projects, as well as then some of them being interested in allowing us to help with consulting. It depends a little bit on whether or not the municipalities have their own existing GIS program, and a lot of it is actually being spurred by the new ARPA funding from some of the federal grants. So they're finding themselves with some money that they can use to implement projects that have sort of been lying around up until now. No problem. Thank you for your question. Are there any other questions?
We have a fair bit of time. Carrie, you finished up a little early. So if there are other questions, please feel free to throw them in the chat. I have a question. You certainly aren't the first rural county GIS coordinator to grapple with this kind of thing. Were there any particular system implementations from other counties that you're able to find and use as a model for what you're going to try to do?
From what I've found, everyone does something differently, especially within the various states that I've been able to locate resources on. I did poll the other GIS directors and coordinators and managers within the state of Pennsylvania, and I did not find very many formal assistance programs. A lot of it depends on where the county's priorities are and whether or not they've had agreements in place, and also it depends on the robustness of the GIS program. Because Pennsylvania is the way it is formed, every department, GIS department, has formed differently. The saying goes that there are 67 counties and there are 67 different ways to do something. So not all of them have the capacity to form this. Within my research, King County in Washington State has been of particular inspiration to how I want to make sure that I form this program, particularly with how they allocate and identify funding and rates and services while also doing individual projects. I have found that I believe they also did an ROI study into how the GIS program has benefited the county over the years, which is also part of what I want to build into this program as well. And I have found lots of pertinent information from both of them.
Good. Glad you were able to find helpful info like that. Any other questions for Kara? Okay, well, thank you, Kara. Nice job. And that will take us to our last presentation for today, which is going to be Jake Haverkost. Jake, are you ready?
Yes. All right, hopefully everyone can hear me.
I can hear you and I can see your slides. Take it away.
Perfect. Well, good morning, everyone. My name is Jacob Haverkost, and today I will be discussing marine navigation systems and augmented reality, a case study of interactive electronic navigational charts. So, as the agenda for the presentation, I'll begin with a brief overview of the project, as well as some background information relating to both marine navigation and augmented reality. Afterwards, we will discuss the goals and objectives of the project, as well as the methodology and anticipated results of the proposed work. And then to conclude, we'll review the expected timeline for completion of the project, as well as a potential presentation venue. So, over the years, advances in technology have greatly improved navigational aids. Modern navigational aids are commonly electronic devices with varying levels of computing power. But one of the restrictions they still have is that they are still using 2D representations of data. On the right-hand side, we can see an example of what one of these devices might look like with some navigational chart information on it that I'll describe here shortly. So, one of the ways that we can possibly improve this representation of data is through viewing it in 3 dimensions. And to do that, we can look at mobile devices such as smartphones or tablets as a possible solution through augmented reality. So on the right-hand side, again, at the bottom of the slide, you'll see an example of Google's implementation for a pedestrian navigation application that also uses augmented reality. And so this project aims to test whether or not a mobile augmented reality application is suitable for marine navigation, and how mobile augmented reality can be used to represent electronic navigational chart information in 3 dimensions. And I'll go through more details about what all of that is here shortly. So, why perform a case study involving marine navigational aids? So every year, the United States Coast Guard reports statistics involving recreational boating accidents. So in 2021, 2 of the top 5 accident types, which were collision with a fixed object and grounding, involved stationary aspects of the environment, which resulted in a number of deaths, a number of injuries, as well as causing over $22 million in estimated damages. So for safety and for economic reasons, there's a room for improvement here in the navigational capabilities accessible to recreational boaters. So, to provide some information on marine navigation, we break it down as the safely traversing a body of water from one point to another while tracking a vessel's position, course, and speed. This navigation typically is along a planned route, but that isn't necessarily a requirement. And to aid in this navigation, vessels are typically equipped with a variety of instruments, many of which are used to measure angles between objects. These angles can be used to calculate position fixes, and then over time you can calculate for speed as well. So for example, a pylorus seen in the bottom right of the slide uses relative angles to help maintain bearing of the vessel, while a sextant, seen at the top right, is commonly used to measure the angle between a celestial object and the horizon for celestial navigation, or it can also be used to measure angles between other fixed or known objects. So as a quick demonstration of how the celestial navigation works, this little animation shows obtaining a celestial object, in this case the sun, in vision, and then adjusting the instrument to bring it down to the horizon and measure the angle. That angle can then be used to look up positional information. Once you have a calculated position and course for the vessel, navigators would typically plot this information onto a nautical chart to help determine the ship's actual location relative to other known features. So a nautical chart is just a map representing hazards, water depths, and a variety of other navigational information. And historically, these were printed on paper, were quite large. It could be multiple feet on one side alone. And over the years, the symbology for these chart features has been standardized. In the United States specifically, the symbology for these charts is defined in a manual called the United States Chart Number 1, symbols, abbreviations, and terms used on paper and electronic navigational charts. And that's been developed by NOAA and MGA. One of the downsides of using paper nautical charts, though, is that you have to keep the information up to date. And in order to do that, you're required to manually plot those changes onto the map. Or if there are significant updates to the region covered by the map, it might require complete replacement of that map. So as technology advanced, digital alternatives have become available to these paper nautical charts. These alternatives are commonly referred to as electronic navigational charts, and NOAA in the United States provides a product by this name. NOAA has actually stated that moving forward, focus will be on their digital product, the ENC product, as opposed to paper charts, in order to improve consistency of the data, the quality of the charts, and also the turnaround time for application of critical updates. To view these ENCs, a variety of marine navigation systems are available. Many of these electronic displays are interactive in some way, whether that's just updating the display based on vessel movement, or even allowing interaction from the user. So on the right-hand side here, you see NOAA's ENC Viewer, which is a web-based online tool for viewing the nautical charts. And this application acts like a typical web map application and allows for the enabling and disabling of certain information, such as water depths and other iconography, as seen on the left-hand side of that image. The electronic navigational chart data is directly available through NOAA's website in the form of individual files, as well as through the use of web services if you're looking to dynamically request that data for an area. And those critical updates that I mentioned before are actually posted weekly by the United States Coast Guard through what are called local notice to mariners. These updates are automatically applied to NOAA's ENC product every week. So next, what is augmented reality? Augmented reality is an experience combining virtual content with a view of the real world, whether direct or indirect, in real time. So a direct view of the real world means the ability to actually see the physical environment, whereas an indirect view of the real world means to see the physical environment through some other means, such as a camera feed. One popular modern example of augmented reality is Pokemon Go, a mobile game published in 2016 that uses augmented reality to display little virtual creatures over top of a camera's view of the user's environment. Augmented reality is commonly considered to be part of a larger mixed reality concept. Mixed reality can be described as any environment that contains both real and virtual content. So augmented reality is typically described as having a real world environment and augmenting it with virtual content. And there's a couple different approaches that can be taken to register this virtual content in the real world. One is a location-based approach, which utilizes the position and orientation information of the device, such as a GPS location, to help anchor the virtual content within the real world. Another approach is a vision-based approach, which actually evaluates the content that is within view of the device, and it uses that information to determine when and where to actually anchor virtual content within the environment. There are three broad categories that augmented reality devices fit into. One is just an electronic display, such as computer monitors or television screens that visualize computer-generated content over a camera's view of the real world. So one common example that people might not think about is television broadcasts of American football games where they show the yellow first down line. That line does not actually exist in the real world. It is only there on the broadcast. Another example is head-mounted displays. So these devices are worn on a user's head, typically with displays in the user's field of view, either with a transparency, showing the real world, or an opaque screen that shows like a camera's view of the world, as mentioned before. So on the top right of the slide here, we have a gentleman wearing Microsoft's HoloLens, which has either augmented reality capabilities or mixed reality capabilities, depending on how you classify it. And then we also have mobile devices, such as smartphones and tablets. These devices are compact computers that contain integrated cameras, powerful processing units, dedicated graphics processing capabilities, as well as global positioning systems and inertial measurement units, such as accelerometers, gyroscopes, magnetometers, to help determine the device's position and orientation in space. So how can augmented reality help with marine navigation? Electronic navigational aids have been suggested to improve safety, but the current set of these navigational aids require a navigator to split their attention between the aid itself and the environment that they are navigating, which has been known to leave a lot of navigators very uncomfortable. And so by taking advantage of augmented reality, this navigational aid information can be overlaid onto the real environment, providing the navigator with a unified view and preventing the need to physically look away from the environment to get additional information. This enables seeing the unseen, so to say, because augmented reality allows for virtual content to be displayed over the real world. Information that would typically be obstructed from view, such as underwater hazards, can be presented to the user. And by utilizing the digital chart information in the form of electronic navigational charts, the systems are also able to stay up to date with the most recent critical information. A lot of research and resources have been placed into commercial systems and investigation into augmented reality in that space, but there is less focus on the recreational space. So on the right-hand side, you can see two examples of proposed augmented reality marine navigation systems for very large commercial or military vessels, and a possible representation of data that can be presented. So the specific goals and objectives for this project are to improve the integration of virtual 3D content into the user's routine life. In this case, that of a recreational boater while they're out on the water. Pedestrian and vehicular navigation receive a lot of attention for AR capabilities, but I'm looking to improve the navigational capabilities, especially in the marine environment specifically. And then I would like to make sure to accurately, within reason, visualize the electronic navigational chart information in 3 dimensions so that that data is anchored to the real world environment. In order to accomplish those goals, focus will be on the presentation of horizontal and vertical electronic navigational chart information in 3 dimensions, and hoping to answer the questions such as, is mobile augmented reality a suitable solution for representing E&C information for recreational boaters? How one can accomplish using mobile augmented reality to present E&C information in the recreational boaters environment, and then how the mobile application can request, process all of that information from the various services in support of that AR-based navigational aid. And there will be development of a prototype mobile application that has all of these augmented reality and data processing capabilities, and then hoping to perform a heuristic evaluation of the application to evaluate the usability of it. For development of this application, it's going to focus on Android-based mobile devices, such as smartphones and tablets. So, as I previously mentioned, mobile devices are very useful augmented reality devices because they come packaged with a variety of systems and sensors that help with the augmented reality capabilities, such as the camera to provide the view of the environment, the processing and graphics capabilities, for data processing, and then virtual content rendering, and then the global positioning systems and the inertial measurement units for helping with device positioning and orientation in space. Specifically, I, as the one running the project, have access to a Google Pixel 5, and then also a tablet that is yet to be determined. And these devices will be the initial devices used for testing the application. Software-wise, we'll use a variety of different APIs, SDK, programming interfaces, software development kits, and libraries that help to support geospatial processing as well as augmented reality capabilities. For Android devices, there's AR Core, which is Google's augmented reality platform for Android devices. And then the Unity game engine is capable of building applications that can be deployed to a variety of different platforms, including mobile devices. So in the future, if this application proves to be useful, it can be tweaked and deployed to, let's say, iOS and other devices as well. There's also the AR Core extensions for AR Foundation. This is a kind of adapter like library that provides Android augmented reality support to the Unity game engine. And then for geospatial processing, I'm hoping to use Esri's ArcGIS SDK for Unity. This was released earlier this year, and actually they have a webinar at 1 o'clock today, if anybody's interested. I would like to use this to handle the different map layers, the projection of data, and the interactions with the geospatial content. If that doesn't work as expected, there are a few different alternatives, of some of which are easier to use than others, such as Cesium Native and Mapbox SDK for Unity. So for the prototype itself, due to some limitations with how augmented reality capabilities interact with marine environments, prior research has suggested that there are some difficulties there. I'll be looking to use a more location-based approach for the augmented reality capabilities. The application itself, without going into too much detail, will follow a common 3-tier software architecture. This simply defines a separation of responsibilities between the interface and the user interaction, the data processing capabilities, and then the data management and data storage. The application should support both offline and online modes. So these modes will mainly depend on whether or not external communication is available, such as whether you have service or not, which can become a little bit of a problem whenever you are out on the water. And this will control where the electronic navigational chart data is retrieved from, whether you're reaching out and hitting NOAA's web services directly, or obtaining that data directly from the device, kind of pre-cached information. And initial testing will use simulated inputs, such as spoofed GPS location and other orientation inputs. And then once the augmented reality capabilities are confirmed and the virtual content is working, I will transition to testing with real inputs. A specific testing location has not yet been determined. So I'm anticipating the successful development of the prototype mobile augmented reality application that is capable of displaying electronic navigational chart data in 3 dimensions on the real world environment and allowing for interaction. The application, as I mentioned, should function both in online mode and offline modes and be able to swap between reaching out to NOAA's servers directly and then also being able to access electronic navigational chart information stored locally on the device. I'm hoping that the anchoring of the virtual content will be accurate within some accepted error due to inaccuracies with the GPS location and the orientation of the device and things of that nature in the user's environment, and then addressing feedback from the heuristic evaluation relating to usability problems and improvements to the device or to the application. As the anticipated timeline, I'm looking to submit an abstract to the presentation venue here shortly and prepare the electronic navigational chart data here in November, as well as testing and investigating the software and any development of backend services that needs to be done at the end of the year here. And then, development of the initial prototype application using those simulated inputs, like I mentioned in January, and then using real inputs in February while compiling results, preparing for the presentation, and actually presenting in March. As a potential venue, I'm looking to submit that abstract to the American Association of Geographers annual meeting this year, hosted in Denver, Colorado, near the end of March. Here's some sources used for the proposal. And are there any questions?
All right, very good. Thanks, Jake. Cool stuff. Questions for Jake?
So Fritz has asked, this is, how scalable is your project idea? So recreational boaters could span quite a few vessel sizes and types. Will your project necessitate the use of a headset? Could your mobile augmented reality idea be displayed on a windshield or screen without the use of a headset? And how much would this system potentially cost the user? Yeah, so I didn't cover one of the reasons why the mobile devices were chosen was due to an accessibility reason. Most people nowadays do have a mobile device of some sort with these capabilities, whether you know it or not. So ideally, there would be very little entry cost to a user because they ideally would have the device already available to them. A headset was specifically not chosen for this for a similar reason. It would require, the purchasing of a new device. Those headsets run into the similar limitations with evaluating the real environment. Things like bright light, the motion of the water, and things of that nature make the registration of those vision-based augmented reality solutions a little bit questionable. And so one of the things you can do is you can use external devices such as more powerful and accurate GPS systems and a variety of other sensors and things to feed information into the application to help with the accuracy of the augmented reality scene registration. But again, that requires additional equipment that, as an entry-level solution, I wanted to avoid right now. But there's nothing to say that that couldn't be added as a peripheral piece of equipment at a later point in time. The nice thing about using, let's say, the Unity game engine for the application development is that it has the ability to deploy the common application to different platforms. So depending on what equipment you wanted to use, whether it was a headset or whether it was something involving the windshield or the windscreen, there are solutions there that you can use the same common application handling and then just have a slightly different presentation with it. The windscreen definitely is something that the commercial vessels, like I showed previously, that type of approach is a little bit more common there than it would be in their recreational area. And for scalability, I mean, this is mainly focused on recreational, so it's usually like shallow coastal or inland navigation. So this is not something that would probably be, great to use out, in the middle of the ocean. You would probably want something a little bit more accurate there because you then lose some of your external communication capabilities. And so you would have to rely on the locally cached electronic navigational chart information, which there's nothing wrong with, but you might be a little bit out of date. Hopefully that answered some or all of those questions. Next, Kara asks, you've indicated making this potentially publicly available in the future. Do you have plans to make it public or create a company to handle legal, business, safety, and large-scale development side? I wasn't actually planning on making this fully public right now. I simply don't have the time or capabilities to do so in my life. Depending on how successful the project actually becomes, though, I mean, that can always be reevaluated. I am not a business person at all. So if anything came to be related to a company, legal or business or safety otherwise, I would definitely require a lot of help in order to accomplish that.
Jake, I know you talked about presenting this at the AAG meeting. I'd also encourage you to think about possibly the Esri Developer Summit, especially if I saw you were going to work with Esri's Unity SDK. If that's a major part of what you're doing that would interest Esri, then think about that Dev Summit. And then I just had a question. You talked about using spoofed GPS location data in your testing, but I really know nothing about this topic, but wouldn't it be hard to really test the app without using real locations and what is actually in the camera view?
Yeah, so as I mentioned, the vision-based augmented reality approaches don't work very well in the marine environment, simply due to a variety of factors, like I mentioned, like bright lights and the constant motion of the water and the reflectivity and stuff like that. So a vision-based approach is very difficult. Previous research has suggested using more of a location or based approach, but also involving or like a lot of orientation inputs of the device. So basically what happens is that you have a virtual scene representing the map, and it's basically a projection of that content. And then based on the orientation of your device and the position, the GPS position, that projection of that map will basically like move in real time. And so the positions end up basically relative to everything else on that projected map, as opposed to being anchored specifically to a visual component in the scene. which obviously isn't great. You would love for it to be, anchored absolutely on the object in the real scene. But that is, much more complicated to do. There are, some other approaches that you can fuse the location and the vision-based approaches in different ways, and possibly use some image processing and things to try to identify those anchoring points. But I mean, it's definitely much more complicated to do it that way.
Yeah, I can understand why that makes sense. Okay, very good. Are there any other questions for Jake? Well, if not,
Thank
as
you.
always, this was a great set of engaging talks. Thanks, Jake. Across a good range of topics. Just a reminder, please fill out the peer review form for today's presenters. I put a link in the chat at the end of Jake's presentation. And thanks to everyone for attending, and best of luck to all of our 596A students on completing your work and finishing your degrees. Have a good day, folks.
Thank you. Have a good one.
Have a good day.